Okay guys, this is section 3.5. In this section, our goal here is to be able to perform operations with matrices. So a little bit of vocab. A matrix is a rectangular arrangement of numbers in rows and columns. The dimensions of a matrix with m rows and n columns we call m by n. So that little x in there means multiplying, or like multiply 2 by 3, okay? So you might see a matrix dimension that looks like 2 by 2 or 3 by 4, okay? That's just what that little x means by. Okay, elements in a matrix are just numbers in that matrix. So say I had matrix 1, 2, 3, and 4, okay? Matrices always have the brackets on them, okay? And an element is just one of the numbers out there. So an element can be 1, it could be 4, it could be 3, okay? Just a number inside the matrix. So one matrix is the singular version, but matrices, we're talking about more than one, so it's the plural form of a matrix. Equal matrices are just matrices that have the same dimensions and equal elements in corresponding positions. So if I use matrix 1, 2, 3, and 4 again, I know that that matrix is equal to this matrix because they both have the same dimension. They're 2 by 2. They have 2 rows, and they have 2 columns. So it's always row by column every single time. Row by column. All right? And since 1, 2, 3, 4, that matrix is the same dimension and they have the same elements in the same corresponding position, these two are equal matrices. So again, here if I have a matrix, an element could be 1, it could be 0, it could be 3, and this one is a 3 column by 2 row matrix. So this is a 3 by 2 matrix. Say I wanted to add matrices though. All I need to do is add together their same positioned element, okay? So if I want to add them, I'm going to take my first elements, A and E here, and I'm going to add them together. Or say I want to add element D and H together, well, that's going to make a new element in the resulting matrix. Same thing if I want to subtract matrices. I need to take the first elements, okay, and subtract them, and then do all the other elements. So if I do C, for example, and I want to subtract its same element there, G, or same position element, that is C minus G, that'll be a new element in the resulting matrix. So in example 1 here, say I want to add these two matrices. Well, again, I'm just going to add up their same position elements. So right now that's 3 and -1. Well, 3 plus -1 is 2. If I add the second elements together, 0 plus 4, that is 4. If I add third elements here, -5 plus 2 is -3. And the last elements together, -1 plus 0 is -1. So my resulting answer here is this matrix, 2, 4, -3, -1. Some more vocab. We call a scalar just a number, a real number, by which you can multiply a matrix. It's kind of like distribution that we'll get to here in a second. Scalar multiplication is multiplication of each element of a matrix by a real number, called that scalar. So again, it's going to be kind of like distribution to all the elements inside of the matrix. So if I want to perform the indicated operation here in example 2, my scalar is -2. So what I'm going to do is take that -2 scalar and multiply it to all of my elements one at a time. So -2 times 4 is -8. -2 times 6 is -12. -2 times -1 is +2. Then in the second row I'm going to get a -2, a -16, and 0. Then lastly my third row, -4, +2, and -14. Okay, so that is my resulting matrix after scalar multiplication. And they're just keeping their same position in the resulting matrix as they did when they were in that previous matrix we had to multiply the scalar by. So in this one, we're going to do the same exact thing, but first what I'm going to do is do my scalar multiplication first. So I have my scalar here 4, and if I do that scalar multiplication first, I'm going to have -8, -32, 20, and 0. And it says I need to add that to this other matrix, -3, 8, 6, and -5. And I'm just going to add those together. So if I add my first elements together, -8 and -3 make -11. -32 plus 8 is -24. 20 plus 6 is 26, and 0 plus -5 is -5. So here's my resulting matrix after doing those operations on them. So basic properties of matrix operations are these 4 here. So A, B, and C, these are just matrices that have the same dimension. So the keyword here is same. If they don't have the same dimension, we can't add, subtract, or any of that, okay? And K here is just a scalar. So these are associative when you add them. They are commutative when you add matrices. And they are distributive by addition with the scalar K. And they are also distributive through subtraction with the scalar K. And lastly here in example 4, I'm going to try to solve for x and y. I'm actually going to solve this time. Well, the first thing I notice is I have parentheses here. Right? So what I'm going to do first is what I'm going to do first here is I'm going to take that scalar 3 and do both of those. Okay? So if I take the first scalar to the first matrix, I'm going to have 15x, -6, 18, and -12. Then I'm going to add to it the scalar to the second matrix. So I'm going to distribute it to the other matrix. And I'm going to get 9, 21, -15, and -3y. And it tells me it's supposed to equal -21, 15, 3, and -24. So I'm going to stop and see here if these line up. So positive 15 plus 9 is supposed to equal -21. Well, I don't know x yet, right? That's one of the things I need to find. So I'm just going to write that out. 15x plus 9 is supposed to equal -21. Now I'm going to check the other elements. So -6 plus 21 is 15. Yeah, that's a true statement. Okay. I'm going to look at the next one now. So 18 plus -15 is 3. Yeah, that's true too, so that's good. And the last thing I'm going to look at here is -12 plus -3y is -24. Well, I don't know what y is yet, so I'm just going to write that one out too. So -12 minus 3y is supposed to equal -24. So I'm just going to solve for x and y. It's just a normal two-step equation. So first over here, with x, I'm going to move that 9 to the other side. So I'm going to get 15x equals -30, and then divide by 15, which will give us -2 for x. So there's one of them, right? Now I need to know what y is. So first I'm going to add the 12 over first. And I'm going to get -3y equals -12, but I need to divide that -3 out of there to get y. So -12 divided by -3 will give you +4 for y. Okay? Could you have first started out with adding on the inside of the parentheses? Yes. Okay? And then do your distributive scalar? Yes. Okay? Since these are commutative and they can be distributive, okay, it's just going to be the same thing as if you distribute it first or if you add it or subtract it on the inside first. So that's why our properties work here when you do these operations with these matrices.